Data science is a new term penned with statistics and math. There is a growing amount of data that businesses and governments want to mine for better insights into their processes. Data science is the new, or if you might want to say, old system for mining this data. It's been around with statistics and mathematicians for quite some time. Some label a data science one of the most popular jobs in the IT world today with great career advancement. But the R language is an open source programming language for statistics, and it's taken over the data science world. Microsoft has now integrated this open source language with SQL Server 2016. Of course, you do need to install something. To use R, you must install the R Service Platform, then integrate into SQL Server 2016. The SQL Server 2016 installation programs has steps in order to achieve this. You have to remember that it is a service, and if you're installing on the same server as the SQL Server services, your DBA or yourself have to take into account the memory disk space it is going to use, as well as CPU usage. There are free client tools. RStudio is one of the more popular ones, and anyone can use it for free. Microsoft has developed R tools into Visual Studio, so users and developers have many options now. The language itself is pretty flush with references for its syntax. The great thing about integration with SQL Server 2016 is the fact that you can combine the data from a database within SQL Server Management Studio with the R syntax as inputs and outputs. So you don't have to export or import the data from a relational database into the client tool that you are using. The integration is simple, and it uses the sp_configure command. This is used in SQL Server Management Studio to enable the script language for R and to be integrated into the instance of SQL Server 2016. So, what is data science used for? The first thing is data exploration. This can be labeled as data mining or just something as simple as reporting. The point of using statistics or prediction is to apply the results to something, let's say to detect fraud, or called fraud detection. There are open source algorithms that anyone can use, created by the academic world. It'll find patterns of, quote, possible fraud. The other is predictive modeling, and this might go into a different direction than fraud detection. You might do something like marketing campaigns, where should a company concentrate their resources possible new or increased sales? If you're not predicting the sales in a certain area, there's no reason to have campaign dollars going to that area. This either saves money or you divert that money to be spent in an area that is more likely to get the sales. So, like all open source projects in IT, R became a go-to for data scientists and for the academic world. And then it has progressed into the mainstream, and it's integrated in applications like SQL Server 2016. Look for another program language in the next version of SQL Server, and it's probably going to be Python, and it's going to be implemented to complement the R integration. So, data scientists apparently have not replaced the hardcore mathematician and statistician, but it has been labeled a great new career in IT. It also kind of complements a DBA, data warehouse architect, or business intelligence developer in order to advance their career a little bit further rather than getting stagnated. This is a new popular career path for DBAs, architects, and even generalists in IT that have an interest in statistics. Data science is born out of an abundance of data. Storage started getting cheaper and faster. Then big data came along, and now the cloud. Data streams can be tied into almost all languages now. And the new term is advanced analytics. I believe this term has morphed from business intelligence to business analytics and now advanced analytics. The data in our industry is being pulled with different terms to express seriousness of the work that can be done with this load of information. There's a lot of preparations for being in analytics, and this term is used for statistics that are beyond the basics. But every DBA or developer needs to get familiar with this because of the times that are looking into the future for software development. So the next path you'll start hearing a lot of talk about is artificial intelligence, even though it's been around in the world. But what you're doing with R, statistics, and data is advancing the data or information behind artificial intelligence. And then that leads to what's called machine learning. You can get this in a cloud with SQL Server Azure today. It seems to be no stop for this advance of using data because every company or process needs some sort of improvement or automation. So data is the key to all these terms, and SQL Server 2016 is serving up all the possibilities to advance your skills in this area. Microsoft is now referring to this space as data platform. There's no longer the need to store everything in a relational database. You can have it memory optimized in a structure, placed in a blob in Azure, or multiple machines linked together to form what's called big data. Don't box yourself in with the new paradigm for analyzing data. R services is installed during the normal installation while creating an instance with SQL Server 2016. The setup procedure from SQL Server 2016 has it as a step and an option. The list of components has R services as a first choice to help using R. This has come from Microsoft's purchase of Revolution Analytics, which has now integrated R into Big Data and now SQL Server. The standalone will install the R services from Microsoft on your computer. You do not have to use this version of open source R. You could install it from somewhere else and then later put the path of R within SQL Server itself. In database is another option that you'll see in the prompts through the components. This enables it to be used inside of the instance in SQL Server and is required if you want to use it within Management Studio, programming and functions, or usage in store procedures. The first step after selecting this is accepting the license agreement. Because it's open source, you'll have to accept the terms and you might want to thumb through them to agree or read and educate yourself about what it means. Do not install it on the same machine as something you might hear. The in-database option enables R integration within the SQL Server relational database engine. This would be the most obvious choice for developers to DBAs who want to get started with R. Installing both R Server and R Service in a single installation. Installing the R Service standalone is typically done because you want to create an environment that a data scientist or developer can use to connect to SQL Server and deploy R solutions. Therefore, there is no need to install both on the same computer. Not everybody is going to use R integrated into SQL Server, so Microsoft offers an R client. This R client is free for download and has useful examples for getting started without the integration into SQL Server 2016 and the data in an instance. A popular option is R Studio, which has been around for a while. This tool has 4 window panes and it's very useful in seeing results from computations as well as graphs. There's a helpful help section in a pane to give the syntax information for what function or option that you are using. Visual Studio, of course, has to be integrated somewhere along the way, and it is. there's a free download. You can add it to your SQL Server installation if you have one. If you don't, go to Visual Studio's Essentials and register for a free copy. Registering here also gives you a free copy of the Developers Edition of SQL Server 2016 Service Pack 1. This is a great tool to start learning about R. Whether you use the Integration and Management Studio, the external R client, RStudio, or Visual Studio, you can begin to learn with many tutorials of how to use R. But to integrate it with data, you're going to want to learn how to integrate it with SQL Server Management Studio. With the installation of SQL Server 2016, we'll look at the option during the installation to enable R integrated into an instance. Of course, with creating any new standalone or adding features to an existing, there's going to be a rules check to make sure that your system is set up and ready to do an installation of SQL Server 2016 or any other edition. This check is going to make sure that it has everything needed, including updates to the files. You'll see the passes or warnings, which you can click on to get more details about. We'll click Next, and we're going to perform a new installation rather than giving it to an existing instance. We're using the free Developers Edition, and we're going to accept the license for SQL Server 2016. Now, once we pick the licenses, it's going to ask us what we need to install. Here, we want the database engine and RStudios in the database. If you notice, our server has already been installed on this machine from a previous installation of an instance. So here we're just looking to get the R services in this particular database. And that's really it. You click Next, and it's already going to know that the R server is installed on this particular machine, and you can install it in multiple instances on a single computer. And it'll ask for an instance name. We'll just call it R. And then you go through the normal installation of SQL Server. Now, let's look at some of the client tools that are enabled with SQL Server 2016. We'll first look at a web page that'll show us some of the information about our setup. Let me see if I can reduce the size real quick, make it a little viewable. And Microsoft does a good job to explain the R services in database. It'll tell you about installing R in a standalone server, some of the prerequisites that are involved, and there's many. And then it'll also give you the options of what's available in 2016. And if you notice here, we have the engine as well as R services in database. But if you notice, they're predicting in 2017, not only do you install the engine, but you'll have this thing called machine learning services, as well as integration with Python. So the R services is only a preview for what's to come with Microsoft SQL Server. RStudio is the free download site of a tool that you can use on a client side to test your R information. I suggest downloading it and playing around with their tutorials first. The other is some of the integrations of R services. There's a great website that tells you how to do the installation, some of the benefits of it, and some of the questions and answers. There's even a blog and information about the new customer product that's coming out for 2017. On my system here, and I'm going to go ahead and cancel this installation, you'll see this Microsoft code. This is one of the client tools that Microsoft has available for using R, and you can see an example of some text, and I could even run this if I would like to. So here we have the integration with R, and inside of a free coding area for R in Microsoft Clients R. The other one is RStudio, and I'll launch it real quick just to give you an example of RStudio. Here we can see the 4 panes that are talked about with RStudio. One has a text file that if I highlight some information and hit Control Enter, it'll actually launch it in this console and give me some information. Over here in the top right is the history as well as the environment. So as you're doing changes to things in R, it's going to display there. There's even one for plots and also the packages that have already been installed. And if you notice here, gplot has been installed on this machine already. So I'm going to scroll down and I'm going to go ahead and launch one of the libraries for gplot, some data, and also display a particular plot. And this, if I can zoom in, well, I didn't install the package first, so let me do that real quick. Get it installed, load my packages, and you can see it's restarting the session and asking me if I want to really do this. And it's actually going to do the installation of the package so I can run a particular graph if I'd like to. Some of the other information that you're able to do is create data frames. Up in here is a data frame, kind of like a table. And if I create it and then display it, you notice down here a similar table is displayed with column names. We can even refer to these columns in kind of a vector space, or even look at all the rows or look at all the columns. We can even reference a column specifically and it'll show us the values. And since it's the only name within the data frame, it'll display clearly. Now that the plot's loaded, let's see if we can get that plot displayed for us. It's going to grab some data and it couldn't find the gplot. We'll look at this later in the next demo. The R language has many syntax, but one of the important ones is the input and outputs. The variable names must follow some rules like valid SQL identifiers, and it's case sensitive. The order of parameters is important when integrating in SQL Server 2016, and it's required that parameters of the input and output have to follow each other, or you have to optionally use some different naming and ordering of these input and outputs. The example to your right shows the input data 1 is a select star from R test data. The output would have to be in the following sequence after a comma, like a parameter. Only one input data set can be passed as a parameter. You can return only one data set. However, you can call other data sets from inside your R code, so you're not limited to one input. And you can return outputs of other types in addition to the data set return to the calling of the script. You can also use an output keyword in a parameter to have its returned results shown. The variables are of course case sensitive, and with that only one input set and returning one data set, you need to watch for the spellings of your variables. It's a typical error to get when you spell something with a camel case and then all lowercase or all uppercase further in your script. There's certain data types, and you need to test your data in advance to verify the columns or values in your scheme that could be a problem when passed to R. Specific columns in your input data source, you want to do those individually. Don't do something like select star. If you know the columns, handle it with their column names. The packages or libraries that are used from the open source. For simplicity, we'll use the rstats package, which is installed and loaded by default with R services. The plots are all kinds of outputs that can come out of here. Really, the statistics might be the first that you'll look at before you look at plots. They're free libraries that can be downloaded to support the plots of all makes. There are ones that you can start seeing now implemented one way or another with Power BI and R integration. Statistics are just basic text that's outputted like a table. They're numbers like mean, median, average, and sometimes variance or standard deviations. So whatever R statistics that you're using, or statistics in general, you'll get the text result as a basis to look at the data before you actually plot something. The SP configure is how you enable external scripts to use the R scripting language. This leads to other scripting languages that might soon be implemented into SQL Server, like we saw in the website about Python and machine learning. If you notice, the SP configure single quote external scripts enabled 1 enables the execution of a stored procedure to execute external scripts. So you're not just boxed in with one like R and everything being implemented as a separate set of stored procedures, which is good in all cases. You call the SP execute external script stored procedure along with the parameters we saw in the previous display. There's an output as well as an input, and text can be then outputted, or you can actually format the image with hex values. This can be saved and displayed elsewhere in a separate stored procedures. The graphs are cool, but of course you're going to need some code in order to display or export that XML, and we'll see various examples of how this is done. So now we're going to look at a demonstration of integrating the R script into SQL Server in Management Studio. Commented out is the creation of a database and also the enabling of the external scripts inside of SQL Server 2016 instance that we have installed. We don't have to run this because it's already been run, but even if you do, all it's going to do is enable that particular system parameter as a value 1, indicating you can use it. Why would you say 0? Well, you might not want anybody to inject external scripts into your SQL Server instance. It's all for security. So if I use that R database, I can create a table that has some test data in it. The values 1, 10, and 100. I'll go to my test script, make sure I'm inside of that database, and here is the execute of the SP underscore execute underscore external underscore script system stored procedure. First parameter at language is R for the R scripting. Our script itself is just creating a variable that pushes input data set into output data set, and then passing as a parameter the input from a select star from a table. So we're going to grab those 3 rows and then put them in a result set inside of R and then outside to SQL Server, and we get just a basic name or table of that value. So you can see how easy this is to pass data around. Here's another one that uses R, does an in out and a select star 12 from a column. Here's our input and here's our output with the result set. So here's an example of an input and an output along with 2 variable names. Well, it'll go something more like a time series where we actually look at a view V time series that has data. Here we're going to use a particular R script to get data about that view. And once we execute it, it should give us that data inside of the R script for the certain modeling of this time series. Now it's taking a little bit longer than I thought, so we'll just skip. Oh, here it goes. So here it gave us the table name along with all the data that's involved in that time series with our calculated column. We'll go to another one called random number. So inside of the R language, you can actually get a list of random numbers. That's what this AS data frame and function rnum norm is going to get from the value 100 with a mean of 50 and a standard deviation of 3. We're going to look at this float values that are returned to us, and now we can see we can get a list of random numbers from R if we don't like the random number generator being used in our SQL Server development environment. There's many more you can do. Here we'll go to our R database and create a car speed table. Now there's internal data that you can play around with inside of R, and this is one of them, a data set. So I'm going to drop and then create a procedure that has a script integrated for the RxLen mod. So it's going to do some statistical analysis inside of a stored procedure, and now all I have to do is execute the stored procedure. The output is a trained model that's in hexadecimal, and this can be copied and saved within a file as an image and displayed elsewhere. And now we're going to actually look at an example of being able to do that. But before we do, let's look at some individual type of normal R scripts that might be used with some adventure work data. So here we're doing a quartile of our ages from the birth date to the get date. So here we can see the standard output for the different ranges, 0, 25, 50, 75, and 100, and the amount of values within that range. So you can see how nice it is to actually use R scripts inside a SQL Server. Here's another one with an input and output into a data frame. And instead of it being text, now we have it in a table that's easily able to be worked with within SQL Server. And then eventually, you might just want to create a particular plot with it. And again, the plot is saved as a hexadecimal. So what do we do with that? Well, someone on the internet, of course, has created something called get rplot in HTML. So this nice little temp path is going to get from the store procedure a formatted HTML document that can use the particular scripting language. And it's real simple, and we already have it created in here. So I'm just going to go to this run store procedure, and then here is my R script that's going to produce a plot. And then the plot is actually going to be able to be displayed. So I'm declaring a variable, putting my script inside of it, then executing that new store procedure, passing that script. Now, what it needs is an input data set. So here I'm selecting the indexed scans and seeks within this particular database. Let me make sure I change it to AdventureWorks first, and then execute this. So as a DBA, you can see how you can create a plot of the particular data about your indexes in a database. And if I copy this file and launch Internet Explorer, or in this case, Chrome, and go to that HTML, I can see the top 10 indexes in a histogram type graph created through SQL Server. So you can see the power of using the R scripting language integrated with SQL Server, and even do an analysis of the data returned through system metadata about your database.